section 6.5 to start. Now, remember, the last few sections were all having the two equations and solving two equations. So we're basically going to do that again. We're just going to do it with the word problems. So let's talk about what to do here. And we'll use this to help us as reviewing. So I have 6 examples here. One of them is a different kind of thing that I'll look at and show you, but the other ones are the ones I want to focus on. Okay, so let's think about this. The title of this is Applying Systems of Linear Equations. Well, the systems of linear equations are when you have the two equations. You have something x plus something y is equal to something, and then you have another one, x plus y is equal to whatever they are, and then you eliminate or you substitute. We're going to take these and we're going to make the equations. So notice, let me get it so we can see the whole thing at once. Roadside vegetable stand sells pumpkins for $5 each, squashes for $3 each. I always thought squash itself was plural as well. But where I got this from actually says squashes, so I didn't know that was a total word. One day they sold 6 more squash than pumpkins and their sales totaled $98. Write and solve a system of equations to find how many pumpkins and squash they sold. So this is a two-part thing. So first we're going to actually write the equations, then after that you're going to solve them. So let's think about that. Okay. We'll put that away. So we have pumpkins and squash. We don't know how many total there are, but we do know that $5 for each pumpkin, $3 for each squash. Well, one day they sold some, but their sales totaled this much. So I'm going to deal with the 6 more squash than pumpkins in a moment. Let's take the amount of money and let's make an equation based on the money. I can't do a simple one like X number of pumpkins plus Y number of squash equals a certain total, because it doesn't tell me what the total is. If it told me they sold 100 things over the day, then that would help. I'd do X plus Y equals 100, but it doesn't say that. What it does say is that there's $5 for each of these and $3 for each of those. Let's make one of these X and one of these Y. Now, in a way, it doesn't matter which one's which, and you can use other variables. Generally, if you take the first one and make that X and the second one and make that Y, then everybody's sort of usually on the same page with that. So I'm going to say X. Well, that's the number of pumpkins, but the price of the pumpkins will be $5 times X. So we have X for the number of pumpkins, but if this person sold 10 of them, that's $50. Okay? We don't know how many it is, but we know that the amount would be $50, or if it was 10 of them, or however many more. And then for squash, we're going to call that Y, and the amount of money would be $3 times Y. And we know that on one day, when they sold some pumpkins and some squash, it equals $98. So we have 5X plus 3Y is equal to 98. Now, to some extent, this is like common sense. It's more complicated than just a simple, thing. And, oh yeah, that makes sense. You have to think about it a little bit and figure out what they're telling you, but it does make sense. It's a practical thing of, hey, however many pumpkins times $5 each gives you that amount of money, and however many squash times $3 gives you that amount. And one day they got $98 selling some. We just don't know how many it was of each. Now, we could put in some numbers and guess, and you could sort of guess and check there, and that could work because there's a number of possibilities. There's probably a certain number of pumpkins and a certain number of squash, and then where you have more pumpkins than squash, and another one where you have more squash than pumpkins, and it might work out that way. But we have another specific thing, and that's where one day they sold 6 more squash than pumpkins. Now the total sales there, if you realize Zelda a bit, but we're going to take just the one day they sold 6 more squash than pumpkins. That alone is an equation. You just have to think about what it means. Now, I'll give you a little hint right now, a little recommendation or a warning. If you just simply go with the words, that's not enough. You have to think about what it means. And my suggestion is going to be to play with a couple of numbers. The thing you don't want to do is just say 6 more squash, so that's 6 plus S, or Y in this case. 6 plus Y equals P. That's what many people would do here because it sort of goes along 6 more, 6 plus. That may or may not be right. what I'm going to suggest is we put in a couple of numbers and think about what makes sense. So I'm going to make a little chart. Pumpkins, squash, so that's X and that's Y. So I'm going to say then, let's say it was 5 pumpkins. So 6 more squash than pumpkins. So if it's 5 pumpkins and there's 6 more squash than that, that means this would have to be 11, because I'd have to be adding 6 to it. Okay? If I had 10 pumpkins, if it sold 10 pumpkins, that would be plus 6 more, because it's 6 more squash than pumpkins, this would be 16. Or if I wanted to think, well, what about for squash? Let's say I sold 20 squash. If it was 20 squash, well, there's 6 more squash than pumpkins, so that means I have to take away 6 from this. You're at 14. It's still a plus 6. So it's however many pumpkins, X pumpkins, plus 6 will give you the number of squash. So see how I made that equation up? Right? There's a number of ways you could think about it. You might figure that out on your own. That if there's 6 more squash, I would either do squash minus 6 is the pumpkins, or the number of pumpkins plus 6. So some people can get that just from the wording. I find it confusing just from the wording. I have to put in numbers and see, oh, here's the relationship. It's this one plus 6, not this one over here. And then I see what matches up, and so I can say instead of 5, 10, and 14, I'll say X. And since it's always plus 6, it's whatever this is plus 6 will give you that one. I could have done it the other way, 11 minus 6, 16 minus 6. I could do Y minus 6, but that's the same thing. I just subtract the 6 on both sides. Now I have another equation. X plus 6 equals Y. So I have just written 2 equations. This is what you're going to need to do. You're going to need to look at something to figure out how to make 2 equations with it. Okay? And sometimes it's as simple as just X plus Y equals a certain amount. Like if it said there were 100 things sold, you'd have X plus Y equals 100, and you've got one equation there. And sometimes it's based on money or something like that, and so it's the dollar amounts. Sometimes they have something like this where you have to think about how to figure it out. Think about what makes sense. This is the way I recommend to do it because it makes sense. You put in a number, figure out what you have to do to get the other one, and then from that you can make it X and Y and make an equation. So that's like part A. Now for part B, we're going to solve it. That means now we're going to take these and do either elimination or substitution. But this one is set up to make substitution easier. It has Y equals this part. These are the same Y's. These are the same X's. So what I can do here is just say if Y is equal to that, I can just plug it in for Y. In other words, that's the substitution method. So for B, I'm going to do 5X plus 3Y equals 98. But now I'm going to replace that Y with this part because that's what Y is equal to. 3x plus 6 equals 98. Now we only have one variable. We just have x's in there. We don't have any y's. So we can now solve for this and figure out what x is. That's the basic thing, by the way, of what algebra is. Algebra is solving for a variable, and you can solve for as many variables as you want as long as you have that many equations. Here we have 2 variables and we have 2 equations. That's equal. That means we can solve it. If we had 4 variables and we had 5 equations, no problem. You got an extra one there. If you had 4 variables and 3 equations, it's impossible to solve that. You have to have the number of equations be equal or more than the number of variables. So we're fine here. We have 2 and 2. Now we've substituted, we have 1 equation with only 1 variable. Let's put these together. So I distributed the 3, both of those. 5x plus 3x is 8x. Combining our like terms. And I'll subtract the 18. And, we get 10. So I happen to use 10 over here, but not because I knew it was the answer. I honestly had forgotten what the answer was. I was just using it as an easy number to work with. It just turns out that it is 10. If x is pumpkins, that means there's 10 pumpkins. And if you add 6 to 10, you get 16. So that means there are 10 pumpkins. And there are 16 squash. And if we put those values in here, okay, now here's the thing, let's check and see, is that going to be right with the numbers? If I put 10 in for 5x, all right, 5 times 10 plus 3 times 16, does that actually equal 98? Well, that's 50, that's 3 times 10 is 30, and 3 times 6 is 18, so that's 48. 50 plus 48 is indeed 98. So that checks. Now I am absolutely certain that I have the right answer. So there's two parts to this. Figure out the equations, solve the equations. Let's look at number 2. It's set up in a very similar way. So it's going to be good to practice that and do the same kind of thing. Okay. It's a little bit different, but it's the same idea, same overall idea. Ramiro earns $20 per hour during the week and $30 per hour overtime on the weekend. When you guys start getting jobs, when you turn 16, you can get a job. I hope you can get paid that much. Most people can't. And in jobs for teenagers, I have a teenager at home who's going to be looking to get a job in about a year or two to pay for his car insurance. But it's going to be hard for him to earn enough because you don't usually make that much money. Hopefully you will. We'll see. Let's look at this example. $20 per hour during the week, $30 per hour overtime a week. 1 week, he earned this much money total. He worked 5 times as many hours during the week as he did on the weekend. That sounds very much like that problem, like that line in the other problem where it was 6 more squash than pumpkins. So you see it's relating one to the other. The first part of this sounds like the amount of money per each thing. So let's think about what the variables will be here. $20 per hour during the week, $30 per hour for overtime on the weekends. So it's hours during the week and hours for overtime, mainly on the weekends. So one of these, so the amount of hours during the week times is going to be one variable. The amount of hours for the other time, overtime, will be the other variable. And I just always like to make the first one X, the second one Y. So now, unfortunately, this doesn't tell us the total number of hours. If it said something like he worked 70 hours, which is way too much anyway, X plus Y equals 70 would be a really easy equation. Instead, it tells us how much per hour, and the total amount. So that is very similar to the one we did here. There was the amount per pumpkin, the amount per squash, and the total amount of money. So now it's amount of dollars. $20 times the hours per week plus $30 times the hours on overtime is equal to that total 650. So now we have one equation. Okay? If we knew how many hours for one, we could solve for the other. But we don't know either of them yet. Okay. But now we use this other information. Now, 5 times as many hours during the week, okay, so it would be easy to say 5 times X equals Y. But let's think about that. Let's think that through. Okay? I'm going to do, too many X's, X and Y. I'm going to say week, and then I'll put overtime here. They're weekend hours, but there's too many words week in there, so I'll just put weekday and then overtime. So let's say it was, if it was 5 hours during the week, 5 times as many hours during the week. I would have to multiply that by 5 to get 25 over here. Okay? Now, does that sound right? 25 hours overtime, but 5 times as many hours during the week. So during the week, he's working more time than he did on the weekend. So this doesn't make so much sense. I can multiply by 5, but now I'm thinking, wait a minute, I don't think that one's going to work. Instead, I'm thinking the number of hours here is going to be 5 times more than that. That means it's something like I'd have to divide by 5. Or maybe let's start, let's do that. Let's start with overtime. If it was like 5 hours of overtime, 5 times as many on the week, so I have to go this way to multiply by 5, and it would make 25. Or if it was 10 hours of overtime, well, it's 5 times as many hours during the week as the overtime, so it's 5 times this number, so it would be 50. So that means it's this one times 5, or I could do this one divided by 5. So I could do the y times 5 is equal to x, or I can do the x divided by 5 is equal to y. So what I modeled here, and actually I didn't know which way it was going first because I didn't remember, I don't have my example here for it. I just know this system works where I put in a number and I see what happens and see which way makes sense to do this multiplying, to do this 5. It doesn't make sense to do it here because then I realize, wait a minute, the week one and the weekday hours are supposed to be more. There's 5 times as many of these as there are those. So it makes sense this one's got to be a larger number. So this one has to multiply by 5. Or this one and divide by 5. So both of these are the same because if you think about this, if I divide by 5, I get x over 5 over here. So really it's just the same thing. It's like 2 sides of a coin. You're looking at something, it's just one looking at one way or the other. But I don't like having it with fractions, so I'm going to stick with this. But that means I like to have, or everybody likes to have, a number in front of the variable. So here is one equation. Here is the other equation, x equals 5y. Now I've got my 2 equations. So this one's not so hard to come up with. This one isn't really hard either, except it's easy to go the wrong way with it. That's why you should plug in some numbers like that to see that what makes sense. Now we can solve it, and this one's easy again because I'll call that part A was to write it. Now to solve it means to do elimination. That doesn't make sense here because it's set for substitution. So let's do substitution. So for B, 20 times 5y plus 30y equals 650. 100y plus 30y equals 650. 130y equals 650. Okay, when you divide by that, you use a calculator, I'm not sure. That was an easy one for me because I already figured that one out. Y is equal to 5. So that tells us there's 5 hours on overtime because Y is the overtime of weekends. So 5 times that would be 25. So 25 hours during the week, 5 hours overtime. Okay, now, I could say that's the whole answer. I might end up losing a point because up here, it asks how many hours of overtime do you work on the weekend? It didn't ask how many hours during the week. I might have needed that in the answer to help me get it, but I didn't really need that part. This is the answer. Give me the answer I asked for. Don't give me like 5 other things with it. So when you get a question, look at what the question is actually asking for. In this case, it was asking for the hours of overtime. And that's what the Y is. So that would be the answer. This is extraneous. It's not helpful. It's good to know, perhaps, but it's not what was being asked for. So you want to give the one that's being asked for. On the last question, it specifically did say how many pumpkin and squash they sold. And so we were able to answer both of them. So some of the other problems are only asking for one thing or the other. So that's important to make that difference. Okay, let's take a look at number 3, because that's another good practice one to do. Anya made 14 baskets during her game. Some of those baskets were worth 2 points and some were worth 3 points. In total, she scored 30 points. So you need to write and solve a system of equations. So 14 total baskets. Some of them are 2-pointers, some of them are 3-pointers. So the baskets worth 2 points should be a variable, the baskets worth 3 points should be a variable, and then you also know the amounts. I'm going to let you take a couple of moments to try to write these equations yourself. I will show them to you in a moment, but I want you to try to come up with them yourself. More than enough room for you to do them, and if you end up with them wrong, you just cross it out and put the other ones down. But right now, figure out the equations yourself. Practice this yourself. Gives you a chance to sort of think about it and try to do it. I'm going to give you 3-4 minutes, 2 or 3 minutes, I think, you're enough to come up with at least one of them. So go ahead and work on trying to do this. Okay, now let's see if you came up with one that would make sense like this. 14 baskets, some of them are worth 2 points. So I made X 2-point baskets and Y are 3-point baskets. And since we know there's 14 of them, we know however many 2-point ones plus how many 3-point ones is a total of 14. So this is one where it's X plus Y, so you've got an easy one to work with. And the other one is almost like the amounts of money was in the last problem. 2 points for those, 3 points for those, so this one's the number of points that you get. You earn 2 points for every one of those and 3 points for every one of those. And it's a total of 30 points that she scored. So this one's based on the number of baskets, this one's based on the amount of points that you get for the baskets. So the equations have a purpose. These equations sort of has a reason for it being like this. Now, you have a number of things you could do. You could move one of these over here and do substitution, or you can do elimination, which is what I did. I rewrote that one, and I took this one and multiplied by 2. So it gave me 2x plus 2y equals 28, because since I multiplied by 2, now I can subtract and get rid of the x's. This is that substitution method in 6.2, section 6.2. So this is one of the things you want to be able to do. On the test, you're actually doing a lot of equations like that. I'm giving you, I think, 2 times I'm requiring you to show substitution and doing it. 2 times I'm requiring you to show elimination as the method to use. And then there's like 3 or 4 others where I don't care which method you use. Here, for instance, I don't care which method you use. I think it's easier to do the elimination, but some people would move the y over after 14 minus y and would find that easier. No problem, whatever's easier for you, just get it right. So here I'm going to subtract 2x minus 2x, those are gone. 3y minus 2y, there's only 1y. 30, take away 28, there's 2 of them. Y equals 2. She only made 2 3-point baskets. So let's figure out the x and then let's see whether or not that makes sense. So if there were only 2 of these, let's come back up here. That means x plus 2 is equal to 14. Subtract 2, that means there were 12. That's saying that there were 12 2-point baskets and 2 3-point baskets. Does that make sense with the amounts here? The amounts of that? If I put that in here, let's sort of check it. I'm going to plug them both into this equation and see if it's right. I already know this one's right because I put the 2 into that to get to the 12. So here, 2 times 12 plus 3 times 2, does it equal 30? That's 24, and that's 6. Yeah, 24 plus 6 is 30. That checks. So that means the correct answer is 12 2-point baskets and 2 3-point baskets. Except now I need to look and see what it is they're asking for. If they ask for both of them, this is right. Let's make sure we're giving exactly what's being asked for. Find how many 2-point baskets. The 2-point baskets is this one. So although this is true, it's not what I want in the answer. So that means there were 12 of them. Okay. So that's how you do that equation, or that problem. Okay. I want you to do number 4 on your own, well, away from me. You can help each other out, talk about it as you're doing it, but I want you to do this with yourself. I'm going to give you about 5 minutes now to work just on this one and practice this one, number 4. first part I will show you to see if you got the right equations. X plus y equals 2,000 should have gotten pretty easily. This one, though, you have to work on it to figure out if fiction books are y, it's 3 times as many of these. That means you have to take the fiction number of books and multiply by 3 to get the larger one. So it ends up being like this. If you had that, if you figured that out, great. If you didn't, it gives you just another way to think about it, to realize, okay, this is how I need to be looking, thinking about this kind of problem. Now, if you haven't already finished solving it, go ahead and do that, and I'll show the answers for that in just a moment. That one's well set up for substitution. I mean, you could force it to become an elimination problem, but it's really actually already set up with x equals to be a substitution problem. So go ahead and put that in there. If you weren't sure where to go with it, I rewrote this one and just simply put that 3y into the x. From there, it's combining the like terms. So you should have gotten to 500 for the y, and that's 3 times that many for the nonfiction. If you got that, good. You got a really good handle on doing this right now.